Hello everyone, welcome to my YouTube channel Tech Pe Charcha with Dpwala. Hope you all are doing good. So let's discuss today's problem from the Leetcode weekly contest. So we'll be discussing the third problem from the contest. This problem has the very less acceptance rate, and I feel like this problem is more over type our design plus DSA based problem, and I can think like this can be a very good problem to ask in any interviews as well. And similar kind of problem has been asked in lot many companies OA as well in the past. So I think like uh, this can be a very good problem to discuss, and this will help you to understand 3 to 4 concepts in a well manner. And if you code this problem by your own, then this can be a very good problem for the interview preparation as well, and as per design plus DSA problem. So let's see this problem. So in the problem, we are given like a M cross and grid, which they called it as a classroom. And what they stated here is like we need to clean the litter that is scattered inside the classroom, and there are some like naming convention that they have used. So basically, S stands for starting from point position of the students, from where we will be starting. The student will be starting. L is nothing but the litter that must be collected. Once collected, the cell becomes empty. Fine. R is nothing but the reset area that restored the student energy to full capacity. So basically, when you reach at this R point at any given time, at any given point of time, then your energy becomes the same as the full capacity. Basically, you get a good amount of energy again, the same amount of energy again. X is nothing but the obstacle of the student cannot pass. So basically, we can't pass through this obstacle, and dot represent the empty space. So this naming is pretty clear to us. So what we need to do here, like we are also given energy, yes, correct, which is represent the student's maximum energy capacity. So basically, RE, whenever you reach any R position, so your capacity becomes same as this energy, and the result the student starts from S. We can move the 4 steps, 4 directions: up, down, left, and right. And when you move from one uh, cell to another cell, your one unit of energy gets decreased from your total energy. So if the energy reaches zero, the student can only continue if they are on the reset set. This is correct. So basically, if you are at the position R and your energy gets zero, then that R will help you to regain the same amount of energy again. But if you are not at R, then you can't move to other cells. So basically, what they want us to do is like we need to return the minimum number of moves required to collect all the litter items. So we need to um, like collect all the trash that is present in the classroom, and we need to tell them like what are the minimum number of moves in which we can collect all the trash inside that classroom. If it's not possible, then we need to return -1. Hope the question is very means clear to you. So we let's discuss with the help of a example. So let's say we are given a grade, assume it like a M cross N grade. So basically, let's consider like this as a M, this as a N, still here. This is M cross N grade, and this is the starting point. Consider it as a starting point. Then we have dot, which are the empty spaces. Let's consider it as a block. We have liter here. We have liter here. Let's consider it like we have R, where you can regain your original amount of energy again. Then, so let's say this is our grade. So what in the question they state is like you can start. You are starting from the S. You need to collect all the liters that is present in the grade in the minimum number of moves. And few observations they means few naming convention that they have used is like dot to represent the empty cells, X is like a blocker, you can't move uh, to that blocker, L represents the liter that you need to collect, and R is like a energy regaining place where when you reach multiple times, if you reach multiple times there, you can gain energy. So you, what you can think, like you simply by seeing this, you can simply think in terms of like a traversal. So this is very easy. Like when you see any grid type of problem and you can see like you need to move one step to another, then traversal is required, BFS, DFS, something kind of that. This is the first hint that, and the first take that you need to see. So let's say we move L, we collect this liter, and then we move this, we again got our energy the same as the starting one. Then we again collected L. If once we collected all the liters at that point, we have a total number of moves that we have taken, and we will simply return that. So basically, uh, this is like a BFS kind of problem, because at every point you need to move, and you can move in any four directions, and moving to the next step level wise is the important thing here. So whenever you think in terms of like a traversal, you need to think in terms of a state, what states we will be using. So let's consider like what state will be required for this problem. So according to me, the states will be like, let's say, as it is a grid, so row and column will be there, I coordinate and j coordinate. So x and y will be row and column, means I and j point where you are standing. The third important thing here is like how much set number of subsets of liters you have collected. So set of liters, let's say liter, count of liter you have collected till this point, you will need to maintain that as well. So basically how you will be doing this. So here what you can do, I will come like how we can use like maintain the count of how many liters we have encountered and all. We can do it this in an efficient manner, so I will come on that once I explain the states. The fourth thing can be like how much energy you have used till this point. And when we can maintain a total, let's say a d value, which is nothing but a total number of moves, like say distance, total number of moves you have encountered. So basically this will be our state. Let's see the constraint here, because if you have this many uh, basically this many states, this many arguments in your state, then you need to have a constraint, proper constraint. If this is fitting in your constraint, then only you can move to the next steps. So let's see that. So what will be the m and n value? It is basically 20 and 20. So this is very good for us. This is very less. So 20 will be a column, 20 will be I and j. And what is the liter they have mentioned? So there are at most 10 liters. Okay, good. So at most 10 liters are there. Now I will explain like how we can do like check like whether we have encountered liter at that particular point or not. So we can do this with the help of a bit mask. Hope you have heard about this concept somewhere, because this is a widely used in CP and DSA. So what you can do, you can maintain a 2 to the power 10, basically, as they have mentioned, like uh, there is at most 10 liters like will be present in the grid, at most 10. So that you can create a bit mask of this size, and at every point what you can do, let's say at the first liter has been collected, so it will be marked as 1. Second has not been collected, it will be marked as 0. Third has been collected, it will be marked as 1. So basically like a set and reset value will be using. If it has been collected, it will be 1. If it is not, then 0. So bit mask plays a vital role here, and it's very good. 2 to the power 10 uh, will be, because 10 is the basically number of liters. So 2 to the power L. And what's E they have given? So basically, uh, what E value they have given? E value is nothing but 50. So energy is nothing but 50. So 50 is energy, and D will be like it will be incremented uh, at every step. So we can't don't take this at the moment. let's consider only these four states. Basically, D is not the one which is changing. This is the one which is we are using for storing our moves. So not consider this. Consider only these four parameters. So what will be a time complexity if we want to apply BFS over these states? It will be 20 into 20 into 2 to the power 10 into 50. So when we see this basically comes out around 10 to the power 7 kind of thing, 2 into 10 to the power 7 kind of thing, asymptotically 10 to the power 7. So it is coming under the tight constraint. So if you maintain your states properly without using any extra space or something kind of thing, and any extra variables, so I think this will be a good and can be easily brute forced kind of problem that you can use here. Basically, in this range, it will automatically comes under our constraint, and we can apply a kind of brute force kind of DFS. So basically, this can be done easily. So what we can do, basically, what we can do at we will maintain a bit set. We will be having a x and y coordinates, and we'll be having a energy at every cell where you are moving. It will be get decremented. So what I will do, I will create a structure of state. It will maintain all these four parameters along with the current distance moves you have taken to reach this point, means like how much moves you have taken. So basically can be easily doable in this constraint. So according to me, this is a very easy problem if you encounter this constraint and got to know that you can apply a BFS. So at every point, what you will do as BFS is very easy, and you have done it lot many times. I I suppose you have done it in lot many places as well. Applied it that in lot many places. So like you will maintain a queue where at every point you will be at a particular node. What you will be doing? So let's say you are at start. So you have four different places where you can move, four directions: up, left, right, down, right? So when you are moving to next, your energy gets decremented by one. And if you are at litter, if you are moving at the next point, if you get the litter, you will simply set that point to 1 in your bit set. And if this is not, if there is no litter, if there is r, so basically whatever the energy you have decremented and whatever the energy you have currently, it will get means you get a new energy which will be same as the starting point, starting where you got the energy at the start point. So it will be a new energy again. Let's say if it's a dot, you can't do anything, and means you basically the energy gets decremented, and if it's a blocker, you can't move. So these four things you need to take care, and you need to maintain. You can move in any four direction, and the base condition that you can write in your BFS template is like whenever you have reached like you have covered all the liters, means your bit set, all the bit set value is 1. Let's say 1 1 1, 5 liters are there, everyone is set, and there were only 5 liters present in the grid. So you will simply return the distance, the total number of moves, this value in the structure. You will simply return that. This is the base condition. Hope you got the intuition behind this problem, what I am trying to say. So like verifying whether this can be fit in your constraint is the first step that you always need to do. You need to analyze the states in any BFS, any traversal problem, what will be the states, and then analyze the constraints. And once you do that, then simply this base condition and what will be the conditions you need to apply, you can easily solve this problem. So let's see the code behind this problem, and afterwards we'll see the time complexity as well. So basically what I have done, I have M and N, row and column. I am maintaining a pair which will be the starting point of that from where we need to start. It will be denoted as S, so I will put that in my pair. I will be maintaining a litter indices where the litter is present in the grid. I have a map which will store the pair where the liter is present and its index. So basically this I want because I am creating a bit mask of 2 to the power number of liters present in the grid. As I mentioned, like here 2 liters are present, so 2 to the power 2 will be the my bit mask size, and I will be setting those values. So basically for that I will be having, I must have this index. And what I will do, if it's S, I will simply add it to my start. This is my starting point. If it is L, means basically liter is present, so I will put that into the my liter vector. And as I mentioned, this will be using, I will be using for my bit mask. So for that particular little indices, I will be maintaining a index. Let's say first liter I got at this point. Let's say this is the first liter, so it will be marked as first. This will be second, so this will be marked as second with respect to its index value. And then I will be maintaining a visited vector, a visited 4D vector, you can say 4D array. So basically its size is 20, which I have mentioned. Basically this size vector you visited array you will be requiring 20 cross 20 cross 2 to the power L number of liters present cross 50. So this will be 2 to the power 10, the maximum size it has been. Basically you need to always think in terms of like what max array size will be requiring. So as either the max liter that is present in the grid is 10. So for the safer side we have created this much, and 51. 50 is the energy, we have taken 51. uh, we have a queue of state. So our state I have defined here, which will be like x comma y comma mass comma energy comma d. Basically only this 5 parameters. D is nothing. I won't count this as a parameter. I count is like a storing move or steps, the answer. And then I will mark the starting point as a visited, and I will push that into the queue. The bit mask is 0 because we didn't encounter any liter, and energy and all will be the same. Then this is my direct direction. So for the like a better code quality, so basically you are moving in 4 directions, so I will be using that. I will be at the starting point. I have taken that first index, starting index. So basically what you will check, the base condition that I have told. If your u dot mask, basically this mask, this bit mask value is all values are set. Basically you encounter all the liters. You will simply return the distance you have like the moves or the steps you have taken that point. You will return that because you have taken all the thrash from that classroom. Basically you have collected all the liters. And if your energy is 0, because you can't, so basically you won't be able to move in to the next cells, so you won't be applying the operations again. If these are not true, basically you still need to collect the liters, and you have still have energy, you will move in the 4 directions. So this is the base condition for that direction. If it's blocker and if it is out of bound, you will not move forward. If you able to move forward, then if when you are moving to the next direction, next cell, your energy get decremented. This is correct. But as I have mentioned here, let's say if you encountered, if you are moving to this cell, let's say R, you have decremented your energy, but this is the R, so your energy gets same as the starting point. So what you will do, you will basically, your energy becomes same as the energy that is at the starting point. And you have the your bit mass. And if let's say you got the liter, so you will mark that particular grid value, like the indexes you have stored in your mask, bit mask. And if that value is this all the parameter nx, ny, and marks and any you got, right? So you will be, if it is not visited, you will be marking as visited, and will be pushing that into the queue, because you need to collect all the liters. So you need to push the elements into the queue which is not visited and which is satisfying our condition. And similarly, uh, once you collected all the liters, basically this statement becomes true, and you will return the most taken. If you don't won't able to collect all the liters, at last you will be returning -1. Hope you got the approach behind this problem. So why I called it as a design type of problem, because here you need to understand like these are the constraints. This is my grade. I need to move like a BFS kind of thing, not a DFS. I need to move in a level wise order. I need to have this much conditions. I have bit mass. So kind of like you need to design, you need to analyze the constraints, and you need to come up with your approach. Hope you got the approach behind this problem. So what will be the time complexity for this? So when you call talk about the BFS, what it is. Time complexity is n plus m, O of n plus m. What is n? Number of edges and number of vertices. So basically n here, our n is nothing but O of these values, 20 cross 20 cross 2 to the power 10 cross 50. And plus m is like 4 directions. So basically asymptotically when you treat, it is nothing but around 20 cross 20 cross 2 to the power 10 cross 50. Means O of this much only. This will be your time complexity, which will be basically easily doable in your this constraint that is given. It's very tight constraint, but applying BFS, and we have restricted our 4 parameters. This one is like for storing. So basically we have only 4 parameters. You can see like in the vector visited vector as well, we have used only 4. So these are the 4 ones which are the changing parameters, and that we need to take care. And as we have fixed all the things and we have used the proper data structures, this is easily doable in the constraints. Hope you got the approach behind this problem. It's like a very kind of implementation based problem and kind of design, as I have mentioned. So you need to read the problem statement carefully, think in terms of like which traversal technique can be used and how to we can brute force our solution in that particular constraint, and we can use BFS and like proper data structure to solve this problem. Hope you got the intuition behind this problem. Hope this will be helpful in your clearing your concept. And as I mentioned, like 2 to 3 concepts are involved in this problem: bit mask, BFS, DSA, important data structures, map, pair, and all. So this is like a very good problem to practice. Hope you got the intuition. If you watch the video till this point, please don't forget to like, share, and subscribe to my YouTube channel and stay connected for more such important DSA problem analysis. Thank you. Happy coding.